When waves, including light and sound waves, hit a surface and bounce back, this is called reflection. So here we've got a mirror. We can have a light ray coming in, hitting the surface and bouncing back again, and this is called reflection. Reflection from a rough surface is called diffuse reflection. When light reflects from a rough surface, an image cannot be formed. So for example, if you looked at this rough wall, you would not see your reflection. Reflection from a smooth surface is called specular reflection. When light reflects from a smooth surface, an image can be formed. For example, you can see here, the water is smooth and calm, so an image of the buildings is formed in the water. We can draw ray diagrams to show what's happening in reflection. So here's a mirror, and we would call this a plane mirror because it's flat. And we just draw diagonal lines to show the back of the mirror. Here we've got a light ray coming into the mirror, and we would call this the incident ray. And as it hits the surface of the mirror, it would be reflected back. So this is called the reflected ray. When we draw these ray diagrams, we would also draw on an imaginary line called the normal line. The normal line is an imaginary line drawn at 90 degrees to the surface in order to calculate the angle of incidence and angle of reflection. So when you draw this line on your diagram, it must be 90 degrees to the surface, so in this case 90 degrees to the mirror. So we use this normal line to calculate the angle of incidence, which is always measured between the normal line and the incident ray, and the angle of reflection, which is measured between the normal line and the reflected ray. The law of reflection states that the angle of incidence equals the angle of reflection. So for example, if we measured our angle of incidence at 50 degrees, the law of reflection states that our angle of reflection should also be 50 degrees. You can do an experiment to investigate the law of reflection. You draw a pencil line on a piece of paper and position a plane mirror, which is a flat mirror, on the line. Use a ray box to shine a single ray of light onto the plane mirror, as you can see in the diagram. Using a pencil and ruler, accurately draw the incident ray and the reflected ray. Turn off the ray box and remove the mirror. So on your piece of paper you should have a line for the mirror, the incident ray and the reflected ray. Where the incident ray and reflected ray meet, use a protractor to draw a normal line at 90 degrees to the surface. Then use a protractor to measure the angle of incidence and the angle of reflection. And you'd repeat this for different angles of incidence by shining the ray box on the mirror at a different angle. So for example, you could repeat it again, but this time have your angle of incidence here and measure the angle of reflection, and again change the angle that the light is hitting the mirror to perhaps here, and so on until you've got a number of different readings. You would then repeat 3 times for each angle of incidence and calculate a mean angle of reflection. And if you collect your data in a table of results, it might look something like this, whereby the angle of incidence is our independent variable because that's what we're changing, and I've got some examples here, 10, 20, 30, 40, 50 degrees. And our angle of reflection is our dependent variable, that's what we're collecting data on. You can see here we've got 3 repeats, 1, 2, 3, and a column for our mean. So we then need to identify and remove anomalies before calculating a mean for each angle of incidence. So I've identified an anomaly here when our angle of incidence was 20 degrees on test 2, because our other readings were 21 and 20, and 30 here stands out as not being close to 21 and 20, not being close to the other readings. So we would remove this before calculating our mean. Notice that if I've measured the angles to the nearest degree, I've also rounded up the mean to the nearest degree. That's important too. So our law of reflection said that the angle of incidence equals the angle of reflection. So when the angle of incidence was 10, the mean angle of reflection was 10. When the angle of incidence was 40, the mean angle of incidence was 40. And you can see for these, the other examples are very, very close, but not exactly the same. So that shows that there is a little bit of error in our experiment. So when the angle of incidence was 20, the law of reflection says that this must be 20 degrees, but we're slightly out here and we got a value of 21. So it could be, for example, these three readings here. Perhaps the pencil line that you drew for the angle of reflection was particularly thick, which caused a little bit of error when you were measuring your angle of reflection. It could be perhaps that you've moved the protractor slightly or moved the ray box slightly as you were sending in the incident ray. There's several things that it could have done, which means that your results might not exactly match your law of reflection, but you can see the general pattern. That would show that the angle of incidence equals the angle of reflection. Specular reflection in a mirror forms an image. You can draw a ray diagram to show how an image is formed in a mirror. And I've just used a really simple image of an arrow just to show this as an example. So if you're looking into the mirror, if you were to see that object as an image behind the mirror, the light would reflect from the object to the mirror and back into your eye, and an image would be formed behind the mirror. The image that's formed is upright, it's the same size, and it's called a virtual image. And the reason it's called a virtual image is these dashed rays in the diagram represent virtual rays. So the actual light rays are reflecting off the object and then reflecting off the mirror into your eye, but that image can't be projected anywhere else. As soon as you stop looking at that mirror, that image is no longer formed. And that's why we call it a virtual image. We can't project it on a screen anywhere else. It is only whilst we are looking at the mirror that we see that image. Hi guys, if you enjoyed that last video, then please click on the screen to subscribe. You can also find all my videos in one place at gcserevisionmonkey.com. If you're a teacher, check out the Key Stage 3 package at sciencesurgery.com. It contains all of the Revision Monkey videos as well as loads more Key Stage 3 resources.